So in this video, we're going to talk about how to use exponential functions to model data. So remember, we can evaluate functions at a specific value of x by plugging it into the function f of x. So for example, if we want to evaluate f of x equals x squared minus 2x minus 3 for x equals negative 2, what we can do is we can take that x equals negative 2 and plug it into our function. So this is going to become f of negative 2. So that means we're going to have negative 2 squared minus 2 times negative 2 minus 3. So if we expand this out, or if you prefer, you can just do it on your calculator. We'll do negative 2 close parentheses squared minus 2 times negative 2 and then minus 3. Okay, so that gives you an answer of 5. If you want to do this by hand, negative 2 squared is 4. So we have 4 minus 2 times negative 2, which is negative 4, and then we have minus 3. 4 minus negative 4 becomes 4 plus 4, which is 8. So we have 8 minus 3, which is 5. Okay, so either way is a good way to solve this problem. So sometimes the data that we're given may have an exponential pattern. In these cases, we may need to use an exponential regression to write an equation that best models the data. So remember, we can write exponential regressions using Desmos or our TI calculator, whichever method you prefer. So let's look at this example. A new mother takes her baby to the doctor each month for a checkup. The baby gets weighed each month. The mother has written down most of these visits. The data she has is shown in the following table. So use your graphing calculator to perform a regression for this data and find an equation of the curve of best fit. So to do this on our calculator, remember you're going to click Stat and then hit Enter on Edit. And then remember you go up and then clear L2, and then go to L1 and go up and then clear L1. So now I'm going to enter all the values of the age into L1 because that's my input variable, and then I'm going to enter all the weight values into L2. So I'm going to go ahead and pause the video so that you can enter these into your table. Now that we have these values all entered, we're going to click on Stat and then arrow over to Calculate. Remember, you're going to go down to 0, which is exponential regression, and you're going to hit Enter. And then keep hitting Enter until you have Calculate, and then hit Enter again. So now it gives us the values that we need to write the equation. So we're just going to go ahead and round this. So we're going to say this is y equals 6.64 times 1.12 to the x. Okay, and so that's the equation of the curve of best fit for this function. So we can also remember do this on Desmos. So I'm just going to show you how to do this on Desmos. We're just going to X out of anything that we already have. You're going to click the plus sign in the upper left-hand corner. And then we're going to click Table. So all the ages we're going to enter into X1 and all the weights we're going to enter into Y1. So I'm going to pause the video while we enter these values into the table. Okay, so now you can see here we have our table of values. So now I'm going to tell Desmos to approximate an exponential function. So I'm going to type y1 is approximately a times b to the x1 power. Okay, so you can see now it gives me my exponential function. So I have these values that I can now plug in. I have a is 6.89. So I have y equals 6.89 times 1.11 to the x power. Okay, so we can now use this equation to go ahead and approximate the weight of the baby at 6 months. So we have this equation 6.64 times 1.12 to the x. So let's go ahead and use that equation. So we have y equals 6.64 times 1.12 to the x. If we plug in the 6 months, right, that's going to be the value of x. So we have y equals 6.64 times 1.12 to the 6th power. So let me go ahead and go to our calculator. And so let's plug this all in. So we have 6.64 times 1.12 to the 6th power. And then when we hit enter, it gives us 13.1. So we would say that y is approximately equal to 13.1 pounds. So that is approximately the weight of the baby at 6 months. So now it says, can we use the equation to predict how much her son will weigh when he's 15 years old? Well, notice that the age here is given in months. Okay, so when he's 15 years old, we're going to have to convert this to months. Okay, so 15 years, okay, and then we're going to have to multiply by 12 months for every year to figure out how many months old her son will be. So 15 times 12, if we do that on our calculator, we get 180. So we have 180 months. So let's plug that into this formula. Okay, so we have y equals 6.64 times 1.12 to the 180th power. And if we do that on our calculator, we have 6.64 times 1.12 to the 80th. 180th. And when you hit enter, we get a very large number, right? So y is approximately, let's write this down, 188,9478. Okay, so you can see that this is not a reasonable number of pounds. So we would say, no, the exponential model is not a good predictor, right? And that's because it's meant for the growth rate around a very specific area of time. And so if we make it, go to much larger values, like when he's 15 years old, it's not going to work. Okay, so the exponential model is not good for very large values. Okay, because that is not a reasonable weight. Okay, so remember that using your calculator, you can model data using exponential regression.